if the production is going up, so everyone will have the money to buy the Tesla Model Y, because the cost reduction, if you can produce lots of cars within 1 year, I mean the cost will be decreased significantly, because I remember the price will drop like 40%. So for example, if you want to buy a 100K cars, then now you only need to spend 60,000. Why not?
Hey everyone, welcome to It's a Material World. We're the show that uncovers why material science will change the world. Consider subscribing and hitting the like button down below. It would really help us out. And before we get started, just wanted to mention that we have released material science merchandise for those of you who want to support us or just express your passion for MSE. You can check out more of the designs at itsmaterialworldpodcast.com/shop or by clicking the link in the description. All right, let's get right into it.
Our sponsor today is Johnson Matthey, a global leader in sustainable technology. Johnson Matthey's vision is for a world that's cleaner and healthier today and for future generations. Johnson Matthey's scientists use their deep understanding of materials, surface science, chemistry, and chemical engineering to design catalysts, advanced materials, and processes, tackling the world's biggest challenges, such as reaching net zero, enabling cleaner air, improving health, and using our planet's natural resources more efficiently. Johnson Matthey, inspiring science, enhancing life. Hi everyone, we are excited to bring on today's guest, Dr. Dikai Guan, the Material Science and Engineering Fellow at the University of Sheffield, as well as a UK Research and Innovation Future Leaders Fellow. His research focuses mainly on the development of high-performance light alloys like magnesium, aluminum, and titanium in areas where energy efficiency is urgently needed, like automotives. As such, we are very much looking forward to chatting with him about the alloys currently making up cars and the future of this industry. Thank you so much and welcome to the show, Dr. Guan.
Thank you very much for the introduction, David. So it's my pleasure to be here to talk about what we have done and what materials are in the cars.
Awesome. So before we get into your focus, which is magnesium alloys in cars, could you start by telling us what metals are used currently in our cars today?
Yeah, the choice of the materials is probably the most important thing for the automotive manufacturers, because if you choose the right material, the performance of the cars will be quite different when you compare to other competitors. So, I mean, if you want to have a material for the cars, you need the material to be, have a high strength, high flammability, and cheap, of course, and has good corrosion resistance. Unfortunately, if you look at the periodic table, then you can find most of the metals and alloys have these kind of features. So as far as I understand, maybe there are top 5 metals and alloys used in our cars. So first of all, it's definitely steel,
right?
Because from the economy side, steel is the most cheap material compared to other alloy systems. It always have high strength, high corrosion resistance, and the flammability is also pretty good compared to other alloys systems. But when we talk about steel, you may be surprised because there may be over 1,000 different types of steels in the world invented by the scientists in the material science research field. That is quite amazing. So it depends on where you are going to put the steel into the cars. If you want to put into the car chassis, then you definitely need to use the advanced high strength steel, because the strength is pretty high, so it can support the maybe 4 or 5 persons in the car. And you can also support the car frame or car bodies. So you definitely you cannot use the pure iron because it's much softer and it's much heavier. So so if you want to use some for example, on the roof or on the bumper, then you also need to use high strength steels as well. So the other alloy system I can think bear in my mind is maybe the aluminum. So aluminum is, I think, the second most used metals in cars, because again, so the production cost is a bit higher than steel, but it's high strength and it also corrosion resistance when the car running in in the rains or in the waters. But the most important thing is aluminum is much lighter than steel. So because currently the governments and the regulations and the policymakers always warning the manufacturers, we want you to reduce the carbon emissions and improve the fuel efficiency. So that's the biggest driving force for the industry to integrate aluminum alloys into the cars, and which is actually very successful in the market. I think. Another alloy I think is magnesium, because I have been working on magnesium lots of times, lots of years. So because magnesium is even lighter than aluminum, so the most benefits is that we can further reduce the carbon emissions, and so everyone is realize how important to reduce the carbon emissions for the Earth. Otherwise, we may end up with no human beings is going to live in the Earth, so that will be a disaster. So the other alloys I can think is the copper, because copper is very conductive, so it's mostly used as electric conductors, to transfer to support the electric powers. It can be also used to transfer the data, or it can act as the sensors. So just imagine if you have a basic car, you can also have maybe the total length of the wire, the copper wire, maybe over 1 kilometers within a basic car, and the total weight could be up to maybe 15 kilos in a basic car, and 20, maybe 30 kilos in a luxury car. And last but not least is titanium alloys. So titanium is actually mainly used for aerospace or aircraft because it's very expensive, but it has high strength and corrosion resistance. So it has great potential to be used in cars. I think the barrier to restrict titanium in the amounts of the titanium used in the cars is the production cost and machining cost as well. So because it's very difficult to machine titanium into maybe car parts, especially for especially if the parts has a complex shape. Yes, that's the 5 material which have been used in the cars.
That's a really good overview of all the different metals that we would see. Another question we have for you is, you kind of touched on it a little bit about the prices and some of the uses, but could you walk us through in more detail which of these metals would be used for like a basic economy car versus a luxury car versus like a super, even an F1 race car, and like what types of these metals that they would pull from?
I think for the basic car, it normally is, the material will be, the metal material will be steel or even iron, because like what I said, so it's very cheap compared to other alloy systems. For example, the production cost of steel may be less than $1 per pound, but for aluminum it will be over $2, and for magnesium maybe it's nearly $5 per pound. So you can see the difference.
Quick question, Dikai, about that. I was just wondering what exactly drives that lower production cost. Like for me, it felt maybe a partial contributing factor is the fact that there's been a lot more time and research invested into mastering and fine tuning like the steel production process. Is that true?
Yes. So it's the production cost is not only related to the raw material, but also related, involved with the machining cost, maintenance costs, and tuning costs, as well as the protection costs. Because if you use magnesium alloys, then you also need to consider how you're going to restrict the corrosion with other metals. And you also need to do some surface coating as well. So there are lots of other costs involved rather than only, the ingot cost.
Got it. That makes sense.
Okay.
I will let you finish your question or finish your answer about economy versus luxury versus supercars.
Yeah. Okay. Yeah. So for the basic one, I mean, you may have just the simple operations of the car. You don't have the entertaining part built in your cars. But for the, let's say for the luxury cars, the body frame may be the material of the body frame may be different. Maybe you will have a aluminum body frame, which is normally, saying in the high-end cars, like some high-end SUV cars. So I think that you can see lots of manufacturers like BMW and Audi and Land Rover and Jaguar. They have released some cars models with the all aluminum car bodies. So which is now in the market, but the price is much higher than the basic one. So if some families don't care about the price, they just want they want just focus on the speed or the manufacturing and entertaining part. Yeah, they can choose the aluminum body cars. So I mean, for the super luxury cars or super high-end cars like the sports cars or F1 cars, because at that stage they don't care about the money. Because they can't afford to buy those kind of cars. They really care about the performance of the cars. So the first thing coming into my mind is the lighter, the faster. So if the total weight of the cars is lighter than any other cars, it means the acceleration rate speed will be much faster. So this is important for the F1. So I mean, at that in that market, then you can add more aluminum or magnesium alloys or even carbon fiber composite into the cars, which will further reduce the total weight of the cars, but the performance will not be decreased. So because if you have lighter materials, the center of the gravity points will be actually moved towards the rear of the car part, which will be useful, to steering the cars easily, or when you do the kind of if you want to have a sharp corner, if you have a sharp corner, then it will be easier for you to drive the car.
Interesting. Okay, and so we'll get into magnesium versus aluminum versus carbon fiber composites a little bit later in this episode, but I was just wondering if we could focus on magnesium for now. And I guess what are the benefits and drawbacks to using magnesium alloys instead of something more conventional like steel or aluminum?
So magnesium, the most important feature is magnesium is much lighter. So it's only have maybe 2/3 of aluminum and maybe a quarter of steel. So which means if you want to reduce the total weight of the cars, then it's possible. For example, let's just make an example. So currently the magnesium only take up maybe 1%, less than 1% of the total weight of the car. So now if we imagine if we increase the total amount of magnesium to 10%, the interaction can reduce the total weight, let's say over 30% of the cars. So that will a big difference. So the carbon emissions and the fuel economy will be changed significantly, which will be all the human beings and even all the animals, all the creatures in the earth will be the beneficiaries, because there will be no extra carbon emissions. So the light density is the most important feature of magnesium alloys. So that is why the engineers want to put more magnesium alloys into the car bodies. So the other thing I mentioned, the other advantage I mentioned before is because the performance will be changed as well. So because the weight reduction improves the performance by enhancing the acceleration and deceleration. So if you reduce the vehicle weight in the front, it will definitely allow the center of the gravity to be moved rearward, improve the response in steering and cornering. So that's another it's not just reduce the carbon emissions, but also improve the performance of the cars. But like what I mentioned before, so magnesium has not been widely used in the cars, and because there are several drawbacks of magnesium alloys. So the most challenging part is the corrosion resistance of magnesium alloys. So because for aluminium, on the surface of the aluminium alloys or steel, it will form a very dense oxide film on the surface, which can actually protect the aluminium or steel part. But on magnesium, the surface is not protected by magnesium oxide, because the magnesium oxide on the surface is porous. So the general corrosion resistance is not as good as aluminium or steel. And the other feature is also because the galvanic corrosion. So when you have two metals touched together, then if you have a high open potential, then it will be anode material. So when two materials touch together, so the galvanic corrosion will happen. And magnesium always was the material which will be corroded severely when you touch with steel or aluminium. And another thing I think is the strength of magnesium. I mean, the ultimate strength of magnesium is not as high as aluminium or steel. So that's another drawback which limits the magnesium applications, because you cannot load or bear the high strength. So that would be a safety issue if you use the kind of soft material as a car chassis.
One question I have is that we talked about a bunch of the drawbacks of magnesium, such as the corrosion resistance being very poor, and the actual strength of material also being poor. In your research, which of these areas is being the most developed? And for some of these things, like it's just not as strong as aluminum, is there really that much that we can do as scientists to improve that material feature, or will we always just have to work around that drawback?
So yeah, that's a very good question. So for example, when we talk about the strengths, there are kind of two concepts. So we talk about ultimate strength, so which is, like absolute strength, like 200, 300 MPa. But there is another way to talk about strength, is like a specific strength. So it's like strength over density. So the specific strength of magnesium is actually higher than aluminum or steel if you consider the density. So that's the kind of advantage. But in most of the cases, the engineers or the manufacturer only care about, the absolute yielding strength or ultimate strength. So that is the what we are aiming to improve, the absolute, the yielding strength or ultimate strength, rather than just, tolerate with the poor yielding strength. So I think in this research field, the researchers have, trying to develop different manufacturing process or alloy design process, or even thermomechanical process, trying to improve the mechanical property or physical properties of magnesium alloys, make magnesium competitive to other alloys like aluminum or steel. So recently, if you look at the literatures, you will find the paper has been increasingly published that several advanced magnesium alloys has been developed either by alloy design or manufacturing processing. So now more and more magnesium alloys have been discovered, which can be used to replace aluminum or steel. But I just want to stress this is kind of lab scale, so it's not like industrial scale. So from the lab scale to industrial scale, there is still a long way to go. So, but the material scientist is not giving up. So we're not just okay. The tensor the strength of the magnesium is poorer than steel. There's no need we need to do. So how about we are not giving up. We're still working on trying different strategies to improve the mechanical or physical properties of magnesium alloys. And I believe maybe in 10 years or in 20 years, magnesium will be very powerful, will be very strong corrosion resistance to replace aluminum and steel in some parts of the cars.
I guess moving on to that second part about the manufacturing, currently we've heard recent news of Tesla's Giga Press, which is at the bottom line, just being able to reduce 100 unique metal parts that each have been molded and fabricated into just one large piece that can be almost injection molded and just pressed together in their factory. How are metal car parts normally made, and how does this new innovation change the outlook on fabrication costs and other things that you were talking about before with challenges of magnesium fabrication?
Yeah, I heard this news, I think in the early of this year, which is blowing my mind. I mean, wow, this technology will change our lives. It's a game changer, definitely. So let me answer your first question. So so for the conventional metal processing, so because the metals can plastically deform at some temperature. So when I say plastically, I'm not meaning metals like plastics. So it's just we use that term to describe this behavior. So for example, if you have a wire and then you can stretch it at maybe 300 or 400, and then so it can be kind of plastic deformed. So because of this feature, it's actually when you do the plastic deformation, you change a lot of microstructure within the material. And that's why we can tailor manipulates the properties of the alloys we choose. So there are different forming technologies. So the first technology coming in my mind is the rolling. So you can have a hot rolling or a cold rolling, or the combination of these rolling technologies. So just imagine you have a thick plate, and then you want to have a thin sheet. Then you just put the thick plates between the mini rolls, and in the end, you will get maybe a thin sheet like 3 to 5 millimeters. So that during this process, you actually, can enhance the mechanical properties as well as the corrosion resistance. So there are other forming technologies like what we call forging. So you just imagine you have a hammer, and then you have let's say you have a pancake, and you're not happy about the shape of the pancake, and you just want to, to make your own pancake. So you just use a hammer to just hammer around, and then you have a different shape. And when you hammer your pancake, let's say the max structure inside your pancake has been changed significantly. So maybe in the end, your pancake will be hardened, significantly. You can't use your teeth, to chew it anymore. So that's the material. After hammering, normally have a strength hardening in the end. So that's what we really want to to improve the strength. At the same time, we don't want to lose its ductility or formability, because otherwise it's difficult to do the machining, or it's difficult to do the forming as well. So we need to use the right parameters to do this hammering or forging. And the other technologies could be stamping, which is similar to forging, as well as extrusion. So for example, if you want to have a pipe or hollow profile, then you just have a kind of a special dies, and then you just inject your material through a channel or through a mold. Then it will come out as a customized profile, like a extrusion bar or extrusion hollow product. So, and you can also use the bending. Just imagine you have a metal bar and you want to bend it a bit, but make sure you don't apply extremely high stress, otherwise you will fracture in the end. So there's nothing you can do other than remelting this material if you want to reuse this material. Yes, that's the traditional or commonly used forming technologies in metals and alloys for producing car parts. Most recently, I mean, in the past decade, so the scientists developed another new technology, which we call a digital manufacturing, which is also called 3D printing. So the concept is like, because if you use the conventional technology, you need to produce a very big block material, and then you do the machining, and maybe you have 10 kilo in the beginning, and for the products you only have 1 kilo. So that will be there will be a waste of the materials. But if you use 3D printing, you can actually just print in a 3D way, and then there will be no waste of the materials, and you can build a near-net shape or complex shape part just in one step. So that is very cost-effective as well. So let's come back to the Giga Press used in Tesla. I mean, Tesla is always doing big things. They're crazy, but they're very ambitious. And sometimes, they push the technology forward. And so I watched that kind of Giga Press video before. I mean, wow. This is kind of, I don't know how to say that. I mean, if this is going to be if this is going to be, a daily job in future, then that it seems like they can produce maybe 1 million cars in a year. So if the production is going up, so everyone will have the money to buy the Tesla Model Y, because the cost reduction, if you can produce lots of cars within 1 year, I mean the cost will be decreased significantly, because I remember the price will drop like 40%. So for example, if you want to buy a 100K cars, then now you only need to spend 60,000. Why not? And yeah, the other thing is, because they use like the Giga Press, it's a giant machine, which is the core technology is the high pressure die casting. So you have the melt, and then it's kind of the dies just inject the melts into the mold, and then you get the body frame or chassis with just one step. And then you can test, like if you have, let's say if you have 10 Giga Press, then you can develop maybe 350,000 chassis a year. And if you have 20, then the production will be doubled. So I mean, although the size of the Giga Press is big, it seems it will occupy a large size of the workshop, but they can do the work. The Giga Press can do the work, which can be only done by maybe 300 robots. So now, if you compare the space they occupy, actually the workshop will be, the size of the workshop will be reduced at least 30% if you have the Giga Press. So I mean, you can reduce the workshop, the size of the workshop, you can reduce the cost of the cars. This is perfect. And you can also, produce the millions of cars in a short time, and you will change the market. I don't know what the other manufacturer is going to do, because if they don't do anything, then Tesla is going to dominate the car market. So they definitely need to do something.
Yeah, I'm sure you're hyping David up with his internship at Tesla. So that's very exciting. And I remember there's parallels with 3D printing with the aerospace industry, from what I've learned at GE Aviation, combining something that was 100 different parts into one 3D printed part. So that's all super fascinating. And I guess just moving forward, one other thing we wanted to talk about is, combining the properties of strength, ductility, and shock absorption. And I was just curious about how light alloys compare to carbon composites when it comes to these properties.
So carbon composites is like usually in the cars is normally the carbon fiber reinforced polymer, which we call CFRP. So the property, the property of composite fiber is perfect in terms of the strength and corrosion resistance, as well as the energy absorption. So it's much better than the other nice alloy systems like aluminum, magnesium, or steel. So it's a perfect material for the cars. So that's the reason why it's popular in automotive industry. The carbon fiber has been widely used in aircraft and aerospace as well. The other thing is carbon fiber is not temperature sensitive, so it is very stable at a wide range of temperatures, which the other alloy systems cannot do that. So for example, the melting point of magnesium is only 650. So if you want to use magnesium at maybe 300, Celsius degrees, that will be very challenging because the strength will be decreased significantly at that temperature range. But the carbon fiber has no problem using in this temperature at all. So another advantage of carbon fiber is the low specific, the low density as well. So the density is even 20 or 30% lower than aluminum. So if you can use a large amount of carbon fiber in the cars, so the total weight of the car will be reduced substantially. I mean, previously when I attend a seminar and someone showed image with a car frame made of steel and another car frame made of aluminum. So two persons can actually lift the car frame made of magnesium. I mean, if the car frame is made of carbon fiber, and then I think one person can lift that kind of car frame. So then you will see the difference between these materials. So it will definitely improve the fuel economy and reduce the carbon emissions. Significantly. However, the carbon fiber is very expensive. It's much higher than the steel, aluminum, and magnesium. But the cost involved, the raw materials, as well as the production cost. So it's kind of you cannot produce this in a mass way. So so the volume, you can only produce a small volume of the carbon fibers. So another issue is the recyclability, because most of the metals can be recycled effectively, even 100% recycle.
Right.
But for the carbon fiber, it's difficult because the carbon fiber reinforced polymer is kind of made of from the non-renewable materials, let's say petroleum. So to fabricate or produce this material is very labor intensive and time consuming as well. So although they have significant advantages over other metal alloys, so there are still some challenges which need to be addressed in future. Otherwise, the volume of the carbon composites used in the cars will be limited. Yep.
Well, cool. I think we've covered a lot of different material choices and different material systems today, and the role of alloys in the automotive space and how material development will facilitate the next generation of electric cars. Considering everything we've talked about today, what advice do you have for young material engineers who want to enter the automotive industry?
Right. I think this is a very good question. I mean, first, the knowledge is very important. So you need to make sure you fully understand the basics and the fundamentals of material science. And I mean, this will be the most important foundation of your future career, especially if you want to address the scientific challenges or invent or groundbreaking technology for the automotive industries. For example, how you're going to, decrease the production cost of carbon fiber, right? How you're going to recycle those carbon fiber in a cost-effective and a green way. That is the biggest challenge in the research field. So all the scientists are trying to make every effort to address this challenge, but it's kind of we're stuck right now. So the future scientists can do this work for the whole people in the world. And the second thing I want to say, because the materials it's not just the problem for the material scientists. This is kind of a problem widely existing in different research fields. So collaborating with different teams from various research fields will be very important for the future engineers. So you need to be open to all the scientists, all the researchers, all engineers, and then put all heads together and propose a solution to address some scientific challenges. And last but not least, I think all the students need to be ambitious. When you face a problem, you think, am I the right person to do this issue? I don't think so. Never say that. You need always to be confident that you are the right person and you will find the right time with the right people to do the right job and address the scientific challenges for the people around you. Yeah, that is my 3 suggestions.
That's great advice. Yeah, I couldn't have said it better myself. And so we definitely learned a lot today about light alloys, how they compare with other materials in the automotive space. So we just wanted to thank you for your time and thank you for sharing your insight into the automotive industry.
Thank you very much. It's my pleasure.
Awesome. Thank you for tuning in to this episode of the It's a Material World podcast. If you enjoyed the show, consider subscribing and hitting the like button down below. And if you'd like to support us on this journey or simply show off your love for MSc, we actually released merchandise. And if you'd like to check out more of the designs, visit itsamaterialworldpodcast.com/shop or use the link in the description. We'll see you soon. And in the meantime, go change the world.